Dilutions. What is dilution? Dilution, diluting or dilution is basically watering it down. For example, here you have lemon juice. Nobody dares to drink it, right? Because it's very sour. Now you add some water in it up to here, and maybe add some sugar in it. You got your lemonade. Now you can, I don't think I know how to spell lemonade, but N-A-D-E. Okay, lemonade. So here, as you can see, you started with lemon juice, very sour. You added water, you diluted, and you now have lemonade. Okay, so basically putting water into a solution is called dilution. All right, it's called dilution. Now, think about it. You had about, let's say, half of the glass of lemon juice in it before you added water, but you still have half of the lemon juice in this after you added the water. So here, the amount of lemon juice didn't change. Okay, it didn't change. So basically, what I'm trying to say here is you guys, when you guys did your vocabulary, moles was the amount of substance that is in a solution, right? So think of that. So if we think of that, the moles, let's say the moles before diluting that lemon juice is still equals to mole after diluting the lemon juice. Okay, moles are equal. That means, okay, you guys know the formula. Molarity equals to moles per volume. Now if I need to solve for molarity, you multiply both sides by volume. Volume cancels out. So moles should equal to molarity times volume. Moles before equal to mole after. If I take that equation, I should get, if this is situation number 1 and this is situation number 2, right? The moles in situation number 1 will equal to molarity 1 times volume 1. And in situation 2, molarity 2 times volume 2. This equation right here is also given in your reference sheet, which everybody should have by now. Okay, so this is the formula we're going to use when we have problems of dilution. Okay, this is just like gas laws. Remember P1 V1 equals to P2 V2? Looks similar, huh? Okay, all right, moving on. I'm going to do guided practice problems. Okay, guided practice number 1. Let's see. Question says, if I add 25 milliliter of water to 125 milliliter of 0.15 molar NaOH solution, what will the molarity of diluted solution be? Which means I need to find the final concentration of that solution right there. Okay, after I dilute, after I water it down. Okay, so let's try this. Okay, so here I say I have, here's my beaker. I have, let's say, volume 1. So initially I have 125 milliliters of the solution of NaOH, sodium hydroxide, okay, which has a concentration of 0.15 molarity. Okay, what they're saying is I will have to add 25 milliliters of water in there. Okay, now obviously after you add water, the volume's going to increase a little bit more, right? They want us to find the second molarity. Okay, now we can find volume 2, right? Because see, my volume 1 was given, that's what I have, and I added 25 milliliters more. That means 125 plus 25, that should give me 150 milliliters. Okay, now I have my M1, I have my V1, I have my M2, I have my V2. Remind me of the formula again. Formula was M1 V1 equals to M2 V2, right? Now in this case, I need to find M2. That means I need to get rid of its friend V2 right here. And to do that, I divide both sides by V2s. V2s cancel. So my formula, M2 will be M1 V1 over V2. Okay, M1 is 0.15 molarity times the V1 is 125 milliliters. Okay, divide the whole thing by V2, which is 150 milliliters. Now, you guys are probably thinking, Ms. Dungana said molarity is moles for volume and volume has to be in liters, but she is still keeping milliliters. Why is she not changing that to liters? Now, that's the thing here. You see, this volume right here is in milliliters. Down here, volume is in milliliters. So milliliters and milliliters will cancel out. So I don't have to do the long process. It's not going to be long, but just, extra step to divide and change these volumes to liters. Okay, so now all you got to do is multiply 0.15 by 125 and divide that by 150. You should end up with 0.125 molarity. Okay, 0.125 molarity. NaOH. That's your